We continue our discussion here in Chapter 5 regarding relationships that occur within triangles. In Section 3 in particular, we're going to focus on angle bisectors of triangles. And again, you already know what an angle bisector is, so we're just going to see kind of how this might relate to a triangle and to just some general cases as well. So, the first theorem we're going to look at is called the angle bisector theorem. It's pretty straightforward. It very closely relates to the perpendicular bisector theorem we talked about in the previous video. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So in the diagram, point D lies on the angle bisector, therefore it is the same distance away from this side of the angle as it is from this side of the angle. Now the important thing to recognize here is that when we talk about equidistant, we're looking for these right angles. You got to be perpendicular if we're talking about distance. The shortest distance is going to be perpendicular. So in terms of words, it says if AD bisects angle BAC and DB is perpendicular to AB and DC is perpendicular to AC, then the distance from D to B is the same as the distance from D to C. Okay, and again, here's the shortest length. So distance means shortest length between the two objects. The converse of that says if we know that a point is equidistant from the two sides of an angle, i.e., we know this, then what that means is we know that this angle must be bisected. Okay, so we know that AD bisects angle BAC here. So in example 1, it says find the measure of angle CBE. Again, recognize two things. One, okay, we're perpendicular. Two, we're equidistant. Therefore, angle has to be bisected. Okay, so angle CBE must be 31 degrees as well. Part B says find the value of x. So again, now we're going the other way. Okay, so we know it's the bisector. Therefore, we know that it must be equidistant from the two sides. So if this is 9, that means x must be 9. Just using the perpendicular bisector theorem. Example 2 says, for what value of x does P lie on the perpendicular bisector of angle J? So if you're having trouble understanding this, draw in the perpendicular bisector. So if that is not perpendicular bisector, I'm sorry, drawing the angle bisector. So if we know that that's the angle bisector, well then what must be true is they must be equidistant. So if this is a 90-degree angle and that's a 90-degree angle, the only way for P to lie on it is if x plus 1 and 2x minus 5 are the same thing. So x plus 1 and 2x minus 5 must be equal. So I'm going to add 5 and subtract x from both sides. So you get 6 equals x. Okay, so x would have to be 6 in order for point P to lie on the angle bisector. For what value of x does P lie on the bisector of GFH? Okay, so again, if P lies on the angle bisector, then that means that these are equidistant. That doesn't really have anything to do with our problem, though. We know that this angle has to be bisected. So in other words, in this example, you'd say 13x must equal 11x plus 8. Subtract your 11x from both sides, you get 2x equals 8, which means that x equals 4. Okay, so again, just using this idea of an angle bisector. It says find the value of x. So the first thing you should recognize here is that they are equidistant and we're perpendicular. So what that means is that this point must lie on the perpendicular, I keep saying perpendicular, must lie on the angle bisector. Okay, so in other words, we know that these two angles now must be congruent. So 2x plus 5 and 3x minus 5 must be the same thing. Add your 5, subtract your 2x, and you get x equals 10. In part B, it's important to recognize this is the angle bisector. This guy's the angle bisector, so we know then that these two pieces, since they're both perpendicular, must be equidistant. So 8x has to be the same length as 7x plus 3. And so all you have to do is a simple one-step equation, subtract 7x, x equals positive 3. Okay? Example 5, do you have enough information to conclude that AC bisects angle DAB? All right, so here's what I do know. Okay, I do know that these two pieces are the same length. Okay, but what I do not know is that whether or not these two angles are right angles. Okay, so if those two angles are not right angles, then we do not have enough information here to conclude that AC definitely bisects angle BAD. Okay, so in other words, there you're going to have to say cannot draw a conclusion, not enough information. Okay, had those two angles been right angles, well then you'd be in business, you'd be fine. Okay, but we don't know that, so there's not enough information there. All right, so that's all we're looking at here in this section is using the angle bisector theorem and the converse of the angle bisector theorem. Some different ideas, but nonetheless, hopefully you feel pretty comfortable with it.